The next part of the question is asking you why you know or how you know that the two triangles are similar. When we have a ladder, a large one, that is parallel to the small one, how do we know that the large triangle formed by that ladder and the small triangle formed by the smaller ladder are similar triangles? Well, because those two lines are parallel and we have an F pattern right here, let me show you it with the wall, we know because of properties of a parallel line cut by a transversal that these two angles are equal. And we can state the same thing down at the ground. We have another F pattern. So we can also state that this angle right here is equal to this angle right here. Now we can see that all three angles in the large triangle are equal to all three angles in the small triangle. And that means the two triangles must be similar. The final part of this question is asking you if we had a longer ladder and we lean it against the wall parallel to the other ladders and we make sure that the base is 5 meters out from the wall. So let's just mark that on our diagram. So out here, this distance all the way across is 5 meters. Question is, how long is the ladder? Well, we can use our similar triangles again to solve for this. In this case, we know how far out from the wall the small ladder is, and we know the hypotenuse. We know in the large triangle how far out from the wall it is. So we can use these two numbers as our scale factor, and we can solve for x in this case, which is going to be the length of the long ladder. So let's write that proportional statement down. I'll write the distance from the wall the long ladder is over the distance from the wall the smallest ladder is. And that has to be equal to the length of the long ladder over the length of the small ladder. Now we cross multiply and we get 5.0 times 2.4, and that has to equal 2.0x. Punch that into our calculator, we get 12 equals 2.0x. Divide both sides by 2 and we end up getting x equals 6.